happy to introduce Michael Toomim and Claus Pörtner, both from the University of Washington. This is work that they did with James Landay. And the full details, I'm going to give you the full time here, so take it away.
Cool. Hi, guys. Okay, I'm Michael. This is Claus. So I'm a PhD student in computer science, and I study HCI. And I was kind of concerned that in HCI, what we really care about, like what really matters to us as HCI researchers, isn't something that we really know how to study. And I came to see that the only way to study this is through economics. So today we have Claus Pörtner here. He's an economics professor. And we've been collaborating on this project to be able to study what really matters to HCI. So I'm going to make a claim that this is what HCI really cares about. So let's go back to the roots of HCI in 1983. So 1983 was when we had our first conference in human-computer interaction called CHI. And in this first conference, the very beginning of this conference, in the first paper session, actually, and the first paper presented in this session, it's kind of a coincidence. This is a paper by Don Norman. Some of you might have heard of him. He wrote some popular books in the field. There it is. Here's the paper. It's called Design Principles on Human-Computer Interfaces. And in this paper, he defines this thing called user satisfaction, or U of X. And he says, this is what we should be measuring. HCI should be about optimizing user satisfaction. User satisfaction is kind of the ultimate in user-centered design. This is paying attention to what matters to users. We want to optimize what matters to users. And it encompasses a lot of different characteristics of an interface. Like you want your interfaces to be efficient and accurate, and that matters to a user. But also things like being user-friendly and learnable, which are maybe a little bit harder to measure. And today there's a lot of stuff that really matters. You want it to be fun, pretty, aesthetic, sociable. These are things that matter to people. And this is all captured in user satisfaction. But we don't really have a good way of measuring this stuff. In Don Norman's idea, we'd be creating these graphs of things like what's the user satisfaction of a menu of different sizes and display times. But in this paper, he just kind of made up these figures. He couldn't measure what they were going to be, so he just said this would kind of look accurate. And in psychology, we use a lot of power laws, so it kind of makes sense to have a power function. And so this is kind of, I said this is kind of a problem that user satisfaction defines our values in human-computer interaction. It's what we want to design for. It's what matters to our users. It's what Google oftentimes cares about. But we don't really have a way to measure this, so we can't measure what matters. And so let's go through the history of HCI a little bit, because this is a growing problem of growing import. Like, we sort of made it so far, but I don't know how long it's going to last. So let's go back to in the 60s. The original interfaces were designed for people who were like nuclear power plant operators or in switchboards. And these users didn't have any choice in what they were doing. So this is the history of choice. The textbook history of HCI is that users slowly got more choice in what they were doing. And as they had choice, it mattered what they wanted. So the original interfaces, since users couldn't choose anything, it just mattered if they were fast and error-free. These were people who were paid to be trained to use the computer. They're paid for days even to use it. And only in the 1980s, users suddenly had the ability to choose different computers. Computers were invading the office. You could buy a computer off the shelf. You could buy different kinds of software. We had advertisements trying to convince you that these things were user-friendly and learnable, because that's what people cared about, because products wouldn't sell unless that happened. And now in the 2000s, we have the internet, and there's so much choice. We have websites everywhere, gazillions of choices. What are people going to choose? The more choices you have, the more that computing pervades your life, the more all of these different types of things matter. So the history of HCI is one of increasing choice in computing. And with increasing choice, there's an increasing diversity of things that matter. And we don't know how to measure all these things. And if you look over the history of HCI, we started out with human factors in the 60s. In the 80s was the beginnings of our field, CHI. And this is when we started to measure user satisfaction, because we started to realize that all these things matter, but we still didn't know how to measure them. And now we're in this era of free choice, and we really have no clue how to talk about this stuff. We don't know how to say, what is a good interface? Free choice is a fundamental value, but we don't know how to measure the factors in it yet. And so in practice, we can see the effects of this at companies like Google. Eric Schmidt says, what we really care about here is getting more users to use stuff. That's what our engineers are at work at. And in some sense, he's saying we want more users to choose stuff, because choice is the issue. All major websites now measure choice with A/B testing. This is how we optimize our products. We look at success in terms of ad clicks, page views, user choice, monthly active views. Success is choice. It's getting people to choose your interfaces. The world is here, but HCI science is still stuck here measuring time and error. So my conference, people tend to still measure and optimize these things. OK, so this is a problem. The gap is growing between our science and practice. And we need to be able to solve this. We need to be able to measure choice and user satisfaction. So let's look a little bit more closely. So I've talked about user satisfaction. I've talked about choice. What's the relationship between these two quantities? I'll say the user satisfaction determines choice. So the idea with your satisfaction is that if you're satisfied with a choice, then that means that you want to choose it again. That's the point of satisfaction. It's sort of your feedback. You're like, yeah, OK, that's a good choice. But the problem here is that if we want to measure user satisfaction, we can't really, because it's inside the person's head. So what we've done is we've said, OK, well, there's this user satisfaction thing. But actually, in economics, there's this quantity called utility. And utility is defined as representing a person's preferences and representing their choices. And the key point here is that we can actually go backwards. Since utility is defined in terms of choices, if we measure a person's choices, we can go back and understand something about their utility. And we can't now, and I just want to clarify, we can't really say that we know what their utility function is, but we can get a measure of utility. We can talk more details about the specific definitions there. But this is what this paper is, or this talk is. So we're measuring utility of a user interface. High-level idea. Utility is a concept from economics. We can measure it today by doing choice experiments. So rather than just give people tasks in an interface and watch them use it, we're going to create experiments where they have choices between different tasks and different interfaces. And today I'm going to demonstrate one method that uses mechanical Turk. And this isn't going to be able to solve all of utility measurement, but this is going to give us one point here, and then I'll talk about the rest of it. So here's our basic method. Yeah?
So dive into something you kind of glossed over. So you're saying at the moment that utility is the best way we can measure this user satisfaction. So 20 years ago, people had similar ideas, but it was confounded by the fact that in those days you paid money for software. And so utility was often measuring things related to actual financial costs as much as it was, there was some complex function of user satisfaction and financial costs where, people were never able to tease that apart. So,
you mean like people measuring user satisfaction by looking at what people pay for software?
Well, no, just what software people chose in various contexts,
Okay.
but a piece of it always had to be what the software costs, because all software costs money. So I think what I'm inferring you to say is now that money is not the issue in any of these things, that the only thing left is user satisfaction. That is, utility is a direct measure of user satisfaction. Do you believe that, or what other things do you think might still be confounded?
Well, maybe we should ask this question again after the talk. So essentially what I'm doing is I am using money in this to get out user satisfaction. We take tasks that people do for free, and then we add money to it to try to see what happens. Okay, so I don't know if we're taking away a confound or we're adding it into I don't know, we'll see. But so let me do the next bullet. So we post variations of interfaces and tasks in Mechanical Turk, but we put them there at different prices. Okay, so Mechanical Turk is a...
But there you're paying the users. I'm talking about the users we're paying, but okay, let's...
Yeah, exactly. Yeah, so we switch it a little bit. So we're paying users. Mechanical Turk is a web marketplace where you can like a lot of people are just on this website, and there's a bunch of tasks they can do, and you can post a task and put a little amount of money for like pennies, and have people do kind of whatever you want. So we're going to take an interface and task, we post it on there, and now we can see basically how much you have to pay people to do your task. But what we really do is we post the task interface at multiple prices, and we record how many are done by each person who sees it. Okay? We have multiple conditions of the interface, the task, and multiple prices. So what we're doing is kind of using mturk backwards from how most people do it. We throw away, we don't care what people actually do if they're actually doing work. They think they're like doing something important maybe, and we just ignore that data and look how much we have to pay them, and we pay them weird amounts. So here's an example of a task we put on there. So this is a Fitts law task. We've run like thousands of these Fitts law studies in HCI. The idea with Fitts law is you have a bar of different widths, and depending on how wide it is and how far away it is from the cursor, we can predict how long it takes you to click on it. And this is pretty much all of the science that HCI has to offer. This is the hard science we have. There's one model, and it just measures how long it takes to click on something. So, okay, this is cool, but we'd like to know how much utility does this have? How much does it matter how long it takes to click on something? So we took these 3 versions of this interface, and we posted them on Mechanical Turk. Now, the way our study works, this is sort of the brief view of how we make this a fair auction on Mechanical Turk. So we hide every task and the pay behind this mystery task interface. Only when you accept it, then we show you, here's the task you get, and here's the amount of pay that you get for it. And you can choose to do it or not, and you can choose to do it as many number of times you want. And that way we get to like track everybody as soon as they see it, and we know how many done it and how many have bailed and how long they did it for. Okay. So here's what happens. We basically have now an A/B test. Well, ABC test because we had 3 interfaces. This is the big bar, medium bar, and small bar. And this is the amount of work that got done on the y-axis. So you can see people like big buttons. They do more work. OK, so that's cool. But the thing that we really added here was that we also added multiple prices. So let's see what that looks like. So we paid people 6 different prices between 1 cent and 6 cents to do this task. So this is 60 clicks. We'll give you 1 penny or 6 pennies. And now we've created labor supply curves. So this is a basic economic analysis. And this shows you not only as we change the interface how much more work is done, but as you increase the price, how much more work gets done. And so you can see now the difference between the price and the interface. And what makes this really cool is that now we can relate the y-axis with the x-axis and see how much pay is this interface change worth. So let's look at the difference between lines B and A. And this depends on where you track it at. So we tracked it right here. This is at 3 cents, or at 3 jobs or something. And if we subtract the difference between these lines, we can see that this interface change was worth 3.8 cents to workers. Okay, so now we have a money metric that tells you how important this is to them. And you could turn this into an hourly wage, or something else that would be great as the next step we haven't done. It would be if we can now predict, like, we can now quantify the change in interface, how much it's worth to people. Well, now, what if you are developing this, you want to deploy this interface change on a real website, and you're thinking, man, if I could make this add utility to this task by 1 cent or 2 cents, how much more work would I be able to, or how much more use would my entire website get? So this is somewhere we'd like to be able to take this. Okay. Okay, so let's, yeah.
The difference between A, B, and C
Yeah.
is the size of the Fitts
Yes.
calculator, right?
Yes.
So in some sense, this could be measuring the amount of perceived pain it
Yes.
is to hit those targets as opposed to user satisfaction.
Totally.
Is that the same as dissatisfaction?
Yeah. So I'm gonna get to that clarification. Yeah, but this is really good insight. So what we were measuring here more of the cost of using the interface than we are the value of doing the task in the first place, right? Yeah.
So can you fit these 3 things onto a Fitts law curve and interpolate and say if the button were somewhere between those 2 sizes, what it would be? Or does it not follow a useful, is the curve not shaped like a Fitts law curve?
So we did this, and it's in our paper, actually, but I didn't put it in the slides. And the curve was, as you it went like this, where as you got,
It did fit pretty well.
it fit well, yeah, but it was convex. As you got a bigger button, it got disproportionately more utility.
Well, if it's over 50%, you don't have to move at all.
Yeah.
Right, okay. That's, yeah. Although, I mean, the index of, we plotted on the index of difficulty scale, which logs it already, so I don't know what that would do. But
By the way, one thing that would be interesting to relate to this is go back and read Frederick Taylor. Because Frederick Taylor was the time and motion guy from 1910. And there's a very nice biography of it from MIT Press. I just read it a few months ago. But he was doing exactly this with physical labor, mechanical tasks, picking things up and carrying them, and laying bricks, and time and motion studies. This is kind of a time and motion study, really.
yeah, it certainly is a time and motion study, but it's more about, but people have more choice.
Well, but the point is, he was measuring how much you had to pay to get these tasks done.
Right, okay.
Oh.
So
Who was that? Taylor?
Frederick Taylor?
Taylor?
Yeah,
Okay.
Ford and Taylor, the
I understand.
firm for modern manufacturing.
Oh,
It's a
yeah.
very big deal.
I'll take it that way. Okay, thanks.
Okay, cool. So, let's sum this up a little bit. So, what we did was we were able to measure the utility of efficiency here. So, this is an interface called a bubble cursor, which is very popular in our field. People come up with crazy ways to click on things. It's like a little bit faster. And we can now measure how much this really matters. We can measure what's the utility of having the start button in the lower left corner so it's easier to click on, and having the menu bar on the Mac up on the top so it's easier to click on. And this gives us the ability to measure efficiency. We can take lots of different principles of UI design. We can start to actually see how important they are. We can start to measure the utility of fun. One thing I'm doing right now is I'm taking this Fitzlaw clicking task, which is clicking back and forth. I'm making it into a game with points and a scoreboard. And my hypothesis is actually, as it gets more difficult, it's going to get more fun because there's going to be some challenge. And then maybe after that sweet spot, it's going to get less fun. And so so we can see some tricky things like that. We can measure the utility of errors, pop up some dialog boxes saying, oh, you messed up. How annoying is that to people? Learnability, we can measure social reward and aesthetics. So let's look at aesthetics a little bit. Here's another study we ran. This is like a prototypical human computation task. Now, and human computation is a great thing to study with utility because you really care about getting a bunch of people to do stuff. It's answering CAPTCHAs. We didn't just care about CAPTCHAs here. What we really wanted to know is, well, what would happen if we took an interface and made it really ugly? So we took this interface and we made it really ugly. We added this bright green background and an animated banner ad. And we calculated the utility difference of this. This was worth negative 0.6 cents for every 10 CAPTCHAs that you answered.
By the way, just to benchmark that, if you think about $1 CPM is a tenth of a cent. So what the advertiser is getting is roughly a tenth of a cent. He's costing the user 6 tenths of a cent.
Oh my God, that's awesome.
Well, I mean, the way we think about it here on the ad side, I don't know if I should be saying this over in the search world, but the idea is you think about the cost to the user of the ad, and the cost to the user, you try to compare that to how much it's worth to the advertiser.
Yeah.
And in this case, it's clearly costing the user more than it's benefiting the advertiser, so it's a bad deal.
Oh wow. Well, that fits my intuition.
We should try this without the screaming green. It doesn't show up quite as green as it actually was, so it's just it was a really sick color.
But it's a nice way to benchmark all of this, all of these kinds of things in terms of ads. So $10 CPM, which is like
That's cool.
ordinary show on TV.
Yeah.
That's a penny a user.
Cool.
So that's how much the TV is paying, about 25 cents per hour of your time. It's giving you, and it's a good metric.
It's really good. Yeah, I'll look this up so I can use it in the future. Thanks.
I wonder, how did you actually measure the 0.6 cents? I mean, fewer people sign up for the task, or did they say, no, I'm not going to do this?
Yeah, we did the same thing as the previous one. So people come up to do the hit, and they get one of two options they can't choose between. And we just measure how much work gets done. So what this means is that in order to get the equivalent amount of work done, the number of CAPTCHAs answered with the ugly interface, you had to pay 0.6 cents more per 10 CAPTCHAs to get the same amount of work done by the average person.
They actually did less.
They did less work, yeah. Or they quit in the beginning, or they quit in the end, or something. And you can actually see over time. So people, I don't have the graph here, but we can see that people care more about aesthetics in the beginning. But the people who do a lot of work don't care what it looks like.
Either that or they're colorblind.
or the.
Well, you did change two things. You changed
Yes.
color and added the jumpy ad.
Yeah.
Yeah, I also removed certain feedback. I changed like 3 things. It's not good science yet, but we can do that later. Yeah. Okay, so here's what, just to summarize what we've shown here. We measure the utility of Fitts law of efficiency. We can measure aesthetics. So this is just like our first steps in this method. We want to see, okay, look, we can measure some basic things that are important. And now with this money metric, we're able to compare the value of aesthetics and efficiency. So in our first steps of this method, like it's got some limitations we'll talk about, but it's also got some really nice qualities. It's very fast and cheap. You can do a study on an interface without an existing user base, without developing the full website. You can just take any random thing and put it on there. So like researchers can do this. And it's easy to rerun a study or to have someone else just give your code to somebody. They can change a little bit and then run the study again, and you can replicate results. Maybe they'll generalize it to some other situations, or maybe they can refute it. You can do real science here that HCI oftentimes doesn't do. So now I'm going to hand it over to Claus Pörtner for a bit. He's going to talk about more the economics and our next steps in validating this.
Quick question.
Yeah.
So the dependent measure there is the number of tasks that got done?
Yeah.
Yes.
Not
Per
the
person.
Not the accuracy, yeah, right. Not the accuracy, and it's dependent on mechanical Turkers being able to just sort of bail at any point. Say, I'm done. I don't
Yep.
want to do this anymore." Okay.
Exactly, yeah. And you could do accuracy, but then we have to measure it, and that's just something we didn't do yet. Yeah.
So for your Fitts law tasks, well, for the reCAPTCHA, I can imagine you could cheat. Yeah, the Fitts law tasks seem a little hard to cheat, although I suppose you could measure the accuracy of whether they actually, because you just sit there and click, 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 and if they figure out they're going to get paid the same for that as they are for actually moving the mouse and clicking.
Oh, they have to move the mouse and click.
Why can't they just leave the mouse where it is and click, which is the fastest way to get through the task?
You have to click on the button as it moves across the screen.
And what happens if you don't?
Then it just sits there until you click on it.
Okay.
It only pays you have to do
All right,
60 clicks.
What's with the reCAPTCHA? Do you have to be accurate for that, or?
Well, you have to pass the CAPTCHA. You have to pass the CAPTCHA 10
Okay,
times.
so there's something in the back end, yeah. So
It's-
that's what I was worried about, is at what point do people start gaming this? Because I know that mechanical Turkers
Yep.
do that a lot. And how have you prevented gaming,
Yeah.
at least at that?
So that's essentially what we're going to be talking about with this. So yes. So
about explore task, you open the right hand to your thumbs.
Yeah, some people actually did. we heard on the third, they're like, this is really easy on an iPad. I was like, okay.
so,
But it was randomly assigned, so I don't think it biased our data.
If they can afford an iPad, why are they doing tasks that's penny and for 60
Right.
clicks?
People, there are amazing people on mechanical.
that's also partly what we're trying to figure out. So. Well, so if nothing else, you can tell that the economist is in the room because the slides got a lot more boring all of a sudden. So this is all based on the whole practice of what we're doing is actually based on probably the most famous economist who ever lived, which is Adam Smith, who in the Wealth of Nation wrote about why wages differ across types of employment. And one of them fits, and most of them fit very nicely with what we're looking at and how we think about people choosing different types of employment. So one of them is agreeableness or disagreeableness of the employments themselves, which is exactly the CAPTCHA version where we saw the screaming green, and we saw the nice white ones. And also something else which is essential to HCI, which is how easy is it to learn them, how hard is it to continue to use them, and the trade-off between those two. The last part are sort of less important, although the smaller great trust, which must be reposed in those who exercise them, is essentially directly the quality part that you mentioned a little bit ago. This theory is also known as equalizing differences or compensation variation. It has a long and storied history in economics, obviously, but it's been something that's been incredibly hard to prove, partly because people choose and it's hard to randomly allocate people to different tasks. And that's one of the advantages of this, is that we can actually do this. So we can directly test whether or not this compensating wage differential holds in real life. And as at least the preliminary evidence indicates that it does. Just to tell you a little bit more about exactly how this works, is essentially we're just taking these two jobs. One of them is type 1 is fun, easy. Type 0 is fun, easy, interesting, nice, whatever. The other one is not. So what we've done so far essentially just have these easy comparison. We then see for a given amount of work how much do we have to pay people, and then we just take the difference. So it does vary according to what type of work you require. But the nice part about it is exactly like Mike said, is we can get a measure of how much do we have to pay people to undertake the less appealing job, or vice versa. How much do we gain by making it more appealing for people to work on this? The way we do this in practice is, right now, as Mike said, what we're doing is we're offering people a wage. And so we have the tasks and the wages are randomized based on user ID. So they don't really get a choice. They just get that particular setup, that combination of an interface and a wage, and then we can observe how much do they actually work. And then we collect some information about where people, about the workers. We know their worker IDs right now. We know where they're from. So the two predominant countries are the US and India. And we estimate this for both US workers and Indian workers. And interestingly enough, we get the same results. The actual amount of money required is going to be different, of course. But we essentially observe exactly the same pattern between the two countries. And then we can estimate these labor supply functions. The one downside of doing what we're doing right now in terms of just randomly assigning people a wage and a job is that it's not going to be very easy to have them do repeat work. And so if we're doing things that are more complicated, or if we're doing things that require sort of multi-step processes, or that where we're interested in studying learning over time, this method is not going to work as well. So the next step, what we're going to do is essentially run auctions. And so the idea is that we give people an interface, and then they essentially bid on a contract saying, how much will we have to pay you to perform a given number of tasks for this interface? So they will be shown the interface. They will be have a chance to try it, see what they think about it, and then we will ask them how much will we have to pay you? And what we then can do is, once we collected all the information for people making their offers, we essentially can start with the lowest bidder, work our way up until we reach a predetermined number of hits that we want to have accomplished. And then essentially we directly get the labor supply function in that case. We need to have the actual work done because people can say anything. And so they might say, oh, I'm willing to do this for 1 penny. I'll do 100 captures for half a penny. But that doesn't really hold any water unless we can actually run the actual experiment. So we need to have people actually do the work. And that's one of the things that we are trying to figure out is how likely is it that people will actually come back and do the work once we offer them the wage. But one of the nice things, if this works, is that we will be able to have the same workers and we can have them do stuff over time. And so we can give them, if we have a more complex interface, for example, where there's ease of use versus ease of learning, then we will be able to follow their offered wage over time and see whether or not, as they become more proficient in using this interface, do the wage go down? How much is that worth that learning experience over time? And that's one of the advantages of the auction method. In terms of what we're also working on is the basic validation of the methods that we have right now. So first of all, our sample right now is relatively small, especially once we divide them up by countries. We had about 300 per country, if I remember correctly, for the captures. So we need a larger sample in order to be able to control for other factors that might be important for how much people work. So we can do countries right now, so we can do India, US, but we can't do time of day, we can't do time of day a week, etc. So we want to control for that as well. We want to have a more precise measure of where people live. So instead of just saying the US, we might be able to say Northwest, etc. And importantly, what we want to do is we want to have a worker survey where we ask demographic information from the workers and we'll pay them to fill out the survey. As with any other survey response, it's a question of how truthful are these. But we can put some questions in there. We'll at least get some gauge of how truthful they are. We can ask them, where do you live? What region do you live in? And we can check that with the IP address. And if it looks like, if they say China and they live in Seattle, then it's probably, the rest of it's probably not going to be terribly truthful as well. One of the other things we're wanting to do is estimating baseline wages. So essentially hourly wages for these, for a given benchmark. And an easy way to do that would use, for example, the captchas and how much would you have to pay people to do this and calculate it into hourly wage. What's nice about it, it will then give us more of a benchmark to hold all the other results to. One other thing we're planning on doing is comparing these, what we're doing with the original lab approaches and say, do they look the same? If they don't, why? Is it because our method is wrong, or is it because the lab results are skewed in some way or another? Another part is to hold this up against A/B testing. There are some things that our method can do better than A/B testing, so we can do sort of more structural parts of it better than A/B testing, but we could still hold this up against A/B testing and say, well, the button, the size of the button, or the famous, yeah, well, I don't have to say, the size of the Google search bar, I assume you all know about that. So that's a perfect example, something that we could do here. We could hold it up against our method. Really what we want to do, though, is try to get at tasks that are much closer to real-world tasks. So first of all, we need more complex tasks. So the ones we've shown here are very easy and very simple to put up. So we want things that are more complex. We want things that are where quality matters, which is exactly getting back to your point. And we want things that have multiple steps in them. And we want, for example, with the multiple steps, we want to see if we split the multi-step process up into individual parts, run the experiment, what results do we get? How do we get it if we run the whole thing in one go? How do the results hold up between the individual steps and the full steps? Does it still matter how the design is made? So some of the examples that we've been thinking about, some of them are very easy, like a puzzle where we remove people move the puzzle pieces by keyboard or by mouse, for example. We can do simple text editing where we give a pre-assigned text that needs to be edited for spelling, grammatical errors, etc. So we actually have some measure of what the final product is supposed to look like. And that will give us a way of getting the quality part into it. Then we have things like file management tasks. Do we use mouse? Do you need a command line? And another thing that actually consists of a series of steps, which is searching and purchasing on a fake shopping site, for example. So Amazon, for example, would be one. They're building, they build different ways of searching and purchasing things on their website. And we could imagine essentially taking that whole process from searching from something to purchase, and then we will be able to observe people along the way and then see what are the end results and which one of these mechanisms works best.
Could I suggest
Yes.
another one, and that is various security and authentication related tasks?
Yep.
Yeah.
Because that's always a problem, right? They're such a pain in the ass, and they're worth something, so we want to trade off the user satisfaction to the effectiveness of the authentication or whatever.
Yes. Right. Yes.
There has been a little work done on that already, but not using this method.
Yeah. Yeah. Unfortunately, we can't search for how to people not to give out their passwords to people who send the emails to them. Like.
Well, I don't know. I mean, there could be various warnings. I mean, you could play a game where if you were spoofed, there was your prize went down, and
Yes.
so you were motivated to try to avoid spoofing.
Or a game
Yes.
where you need 5 different passwords.
Yeah, something like that.
Yeah.
So why can't you try and extort people's passwords out of them? To me, it seems you've already crossed the line. By paying people money to solve captchas for you.
Yes. Yes.
Attack on Gmail, thank you very much.
Yeah. I guess we could actually. Now that I think about it, it's just.
But by the way,
Yeah.
if you want a buzzword here, I've called this kind of thing nanoeconomics. So microeconomics is about the person or
Yes.
the firm, and nanoeconomics is going down to the task or the business.
Oh, that's pretty cool.
Yeah.
I like that. Idea.
Yeah, that's a nice word. So,
It fits a concept in my mind already.
yeah.
Thanks, Al.
Yeah.
When should we quit at 45 or something? So we've got like 10 minutes?
Yeah, you got it. 10, 15 minutes.
Okay, perfect. So I'm almost done here. So some of the important consideration here is the ease of learning versus ease of use, and that's what we will eventually like to get to. And we need to run the longer term employment to study these. Then we also have this might seem like just pure economics to the rest of you, but there's some questions here that are sort of important both for economics and for the studies. So some of them are what's called the law of one price, whether or not you get the same labor supply function. We're using the different methods that I talked about. How do people set and update prices? And reputation effects. And so these are, I'll talk about each of those in just a slight more detail. And they're important not just for economics, but they're also important for our method to make sure it works. So one of the big ones is what's called the law of one price, which is essentially saying that you can, if you offer two things, like in our case, we offered a job. If you offer the same job at two different wages, people will only do the high-paying one. And so we can test this by essentially doing exactly that, offering the same job, and say, do people actually go to the job that pays the most? I mean, essentially, we should see no work done on the job that pays the least amount of money. If we don't, we have to figure out why that is. You could imagine there would be search costs, for example. And Mechanical Turk is a nice way of testing that because the tasks come up on different pages. And so depending on how far you have to click to or how much search you actually have to do, we can then see how much work do we get. And so this will give us an idea of something we can actually test directly in economics, and has implications for which people take up our task and which people are actually doing our work. And so it's important for validating our method. Then there's the price setting part, which is especially important for the labor supply, since we're estimating labor supply curves. And again, it's fairly easy to do. We run the offered wage method versus the auction wage, and we should, in principle, get the same labor supply function, minus maybe a little bit of search cost or a little bit of transaction cost for the auction version, because people have to think about how much they do, they have to put in a number, and there's a little more steps involved. But in principle, they should look alike. At least the relative differences between the different tasks should be the same. And it will give us some idea of how rational are these workers, and how reliable our results are, and how many people do we need to have to do it. We can also test to what extent people are influenced by outside information. So we can publish various amount of information about other people's, what wages other people offered, what was the last wage that we paid, what does the labor supply function looks like, etc., and see to what extent people change their behavior based on that information. And then finally, we have the reputation. So each worker on Mechanical Turk has what amounts to a reputation. It's not actually reputation. It essentially says how many tasks have they completed to the satisfaction of the employer, and we call that reputation. And one of the interesting things we found that sort of initially threw us off a little bit is that we were finding lots of people who were working for 0 cents. And that was just odd. I mean, especially for an economist, that shouldn't happen. Probably more odd for me than for other people. But what turned out what happened is that with the Fitts law, you would get a correct, it would count towards your reputation essentially. And so you were willing to work for free, or what looked like it was for free, because there was a benefit to you in terms of your reputation, and you can then go use that on other tasks on Mechanical Turk. And so we can actually test this by randomizing how many credits you get for running these tasks. So whether or not you get 0, you get, well, we have to give them 1 at least, if I remember correctly. But whether you get 1, whether or not you get half of them, or you get all of them, or even more, for example. And so we can then see how much of an effect does that have. And one of the things that's nice about this is we can actually see how good is this reputation effect at predicting quality once we get to tasks that are actually quality related. This is important, especially for these more complex tasks that I was talking about, but it's also important because it might potentially bias our results if we don't take account of this. because at the low wages, it looked like we're getting more work done than we in some sense really should have, because people are working to enhance their reputation within that. And then pass it over to Mike for future work.
All right, so it's important for us to.
How much do we get paid for looking at that font?
Yeah.
Thanks, Sal. I'm glad you're here. It makes it much more fun. So what I'm going to be talking about now is more like the broader space, like stuff that, like, so far we've just been presenting this one method that we've been doing, but this is just there's a general state space here of utility measurement, looking at preferences, looking at choice, of which you guys know a lot about with A/B testing, and boom. Here's A/B testing in the upper right. So I think moving forward, this is just important for HCI to tackle, but there's a lot of different methods and a lot of stuff here. So this is a way of visualizing the space. We have labor market methods like Mechanical Turk. You can also do preference measurement using existing websites on the right, like A/B testing, okay? So this is our method in the upper right, upper left. The A/B testing is in the upper right. I'm going to go into these other ones in a bit, but first let's just compare these two a little bit. So A/B testing is not very good for early, okay, no, but I have not done regular A/B tests. You guys are the expert. This is my intuition. I'm just going to suggest some things. A/B testing is not very good for early stage designs and mockups because you have to develop and deploy a full website, okay? So now we can test some early idea, something that's not going to be like a fine-grained tweak, because we don't need to fit in a system. Also, we can now allow academics and independent designers to run preference measurement because they don't need access to Google. They don't need access to a full existing user base. You have Mechanical Turk, and it's just got a bunch of users sitting there for you. This is great for us. We can do science experiments that we couldn't do before. This is kind of why we're stuck setting time and measurement in academia. We can also learn why more easily. So in A/B testing, it's oftentimes you learn what, but you don't learn why. There's two reasons why we learn why. One is that when we're paying users, they kind of love doing surveys. It's hard to get a user of your website to take a survey. You get a small sample size. But Mechanical Turkers, you pay them an extra penny, and they're like, oh, yeah, I'll tell you everything about this. And we also have freedom to control these tasks. If you're Google, maybe you would like to understand the utility of your page layout on the search without having the actual search there for some reason. Maybe you just want people to be browsing, and you want to isolate the browsing. But you can't remove search from the actual website to do an A/B test. We can do weird things on Mechanical Turk, like having people click on buttons and answer CAPTCHAs. Okay, so this lets us, by controlling the interface, we can control and isolate different factors and do science experiments that tell us more about what's going on. And this money metric is a very powerful way to communicate results. Now you don't just say, hey, I got 20% more conversions. Now you say, I just gave 5 cents to my users. And if you have 100,000 users, then you have like 500,000 cents, which is a lot of cents. Maybe it's not as much dollars. Okay, so let's look back at this space again. So the labor market approaches. So we did this existing labor market. We just used Mechanical Turk. But you could also roll your own. And apparently Google has almost a labor market. This is what Dan was just telling me, and that's really cool. I would love if we could add some sort of bonus payment to that, and we could start doing utility measurement. My mock-up is like, here's in Gmail, you have this little ad over here, beta test for Google, and you can start earning credit. So this is a way you can recruit people to your labor market and then set up a little labor market. Have people do different tasks for different amounts of money. This is how Mechanical Turk was started. Amazon put a bunch of ads on their website and said, hey, we're going to pay you pennies to fix the information our publishers give us about our books when they put database fields in the wrong place. So whenever you have a problem with Mechanical Turk, this is a way to solve it. You can control anything. You can control your demographics. It's very useful for all of that. On the other hand, there's methods with existing websites. Oh man, this font's not readable. But well, you have
some money, we'll read it.
yeah. Never ending. This is great. Well, it's not that useful anyway, the text. So you have your traditional A/B tests. We can augment them with pay now. So let's say you start paying people different amounts of money to create reviews on Amazon. Now you can get labor supply curves, and And you can get all these same things on existing websites. The reason why you might, okay, so why do we have these two sets of methods? Underlying all this, think of the utility as consisting of both the value of accomplishing the goal and then the cost of using the interface. Okay, so usually like you want to get something done, but you have to go through this crappy thing on a computer in order to get to your goal, and this is why we do tasks. The way this is a nice way to separate it is that on the labor market, people aren't pursuing natural goals. Instead, we're paying them money. So we can't measure this value. We just can't measure it. What we do measure is the cost. So this lets us isolate the cost, but we can't measure the value. Unfortunately, measuring the value is really important. Like, that's what makes websites work. You care about the value. Well, so that's why we have existing website methods, because this measures the overall utility. A/B test is just, let's see how much value there actually is to people, how much work it's done. And now if you can use these methods, you could probably triangulate and subtract one from the other to get at the value. It's just hypothesizing, but I think it'd be pretty cool. Let's move a little bit forward. So let's talk about the hard thing about running these studies, which you alluded to, is how do you get these people to do what you want? How do you get mechanical Turkers who might want to do all sorts of other weird things? So imagine that your tasks, maybe this is like all the different things you might do on Facebook in one session. And there's different scopes at which you could test this. Maybe you're clicking on a button in that little scope. At a bigger scope, maybe you're sending an email. And bigger overall scope, maybe just using Facebook. And you can, when you run a study, you get to choose which scope you're going to have people do. What's the task? Are you going to say use Facebook? Are you going to say click this button 60 times? And each one is going to have different characteristics for how you want to ensure people do the right thing. So clicking the button, you can just test that automatically. That's what we did. OK, the computer can tell, yeah, you clicked the button or not. So that's easy to do. And then you have an incentive system, which is if you don't click the button, you're not going to get paid. If you're sending an email, well, now there's different ways to send an email. You could write a really nice email where you could just type a couple of characters and click the button. So now you want to test the quality of that email. Okay, and the way to do that is to take this text, send it to other mechanical Turkers, and have them grade it. And for even more open-ended things, you might want to record the screen session of the worker, okay, and have other people verify, yeah, you're doing kind of what we want you to do. And you want a trusted beta test pool, probably. This is, I don't know if this is going to work, but this is speculation, things you might try if you want to do these kinds of studies. Okay, so almost done. Here's an example of a science experiment that I think would be really cool to do. Okay, ADD is a big problem, and it really determines a lot of how the internet works. Like, why is Twitter successful? Maybe more successful than blogging now. A lot more people seem to tweet than blog. People don't, it's really hard to get people to put extended attention on the internet, like to attend to something for a long time, just like it is with real life now that everyone's got ADD. And it seems like this maybe determines a lot of the shape of the internet, determines which tasks succeed. We can start to measure this. So like, what is the cost to getting someone to write a small tweet versus a longer one, you know, if it's of the same quality, versus something even longer, like a full paragraph that's thought out. What's the cost there? What's the cost of a whole article? So I would hypothesize that maybe the graph might look something like this. On this axis is the length of the thing you're having them write, and here's the cost of getting them to do it. And it's probably not going to be linear. Having them do something big probably has some curve to it. And the amount of bend in this line might be a characteristic of the user population, of their level of ADD. And you could try running this by recruiting people from YouTube, which maybe is very ADD. Maybe if you recruit people from Blogger, right after they finish writing a long article, maybe they're not so ADD. And it would be a useful way to characterize the way the internet works. So let's conclude. Economics meets HCI. This is HCI's first science of choice. And I think this is very important for the future of the internet. This is important for how we understand things. The way the internet's going is we have a lot of things like games we have to design now, which, you know, people spend money to have choices, ways for them to spend their time, like compelling ways for them to spend their time. And it's all about the utility of these choices that you're giving them. Crowdsourcing is a really exciting new field that depends on finding ways to motivate people to do tasks. Web surfing, there's a bunch of things here that I just think are totally interesting. Attention economics is this theory that we're now basically measuring attention economics. It hasn't really been measured before. And so I think this is the future of HCI. This is my screensaver, but this is what matters to us as a field is measuring what people will do, measuring the utility. We have this history in HCI of borrowing methods from different fields like cognitive psychology and ethnography from anthropologists and other social sciences now. But these don't really fit what we care about. These don't help us design the interfaces and measure what matters. So it's time for us to develop our own methods to solve our own problems and measure what matters. That's it. Thanks. Also, I'm just really excited to be here and hear everything that you guys talk about because I just feel a lot of resonance with Google, and I would love to like understand really what's going on and see if there's some collaborations or something.
Do you mind turning that off? That makes me sick.
Thank you. So I have one comment about what I think would be a very interesting task. We supported some work by Yan Chen at the University of Michigan, where we took 2,000 queries from Google, did duplicate elimination, got them down to questions that you could figure out what people were asking, so it turned out it was about 600 questions. And then she took one team of students and sent them to the library to answer the questions, and the other team of students were sent to Google to answer the questions. And we measured the time to completion. So it turns out it takes 22 minutes to answer a question in the library, and it takes 7 minutes to answer it on Google out of this list. But one of the interesting things that they reported back was that there was a much, much higher satisfaction. The survey, the students found it much easier, much better, even for the same accuracy, even accounting for the time difference.
More satisfying on Google or in the library?
Google. Yeah. So it'd be quite interesting. I mean, they must have
pretty cool.
preferred that. So of course, all we measure from the survey is how much is that they did prefer it. We had no idea of how much they preferred. So you, according to your method, you'd presumably pay them different wages to answer this. And then one last point, just is something that people really misunderstand about utility. Yes, you could pay in money, and that's very convenient, but you could pay in ice cream.
Mm-hmm.
You could pay in chocolate. You could pay in anything. You know, just how much, in order to do this task, how much ice cream do you have to get to make your bed, you know, or how much of this, whatever. So it isn't necessarily tied to money. It can be other trade-offs as well. But I think money is the most natural for communication means.
Thanks.
So I'll rephrase one of my earlier questions in a different way based on something you said. So you talked first about doing these things based on efficiency, and that that's what you're doing with your Fitts Law tasks. And then you talked about now you're trying to establish sort of the same task but in a game atmosphere, and that you think the relevant metric is really a measure of fun. They'll pay for the maximum amount of fun. So how do you understand the trade-offs? How do you know that that isn't that they aren't maximizing on efficiency, or that in the Fitts Law case, the pure Fitts Law case, they weren't looking for fun or something like that? Given that user satisfaction is this multifaceted thing, how do you know what facet you're looking at?
You never really know for sure. It's always, I mean, these are just like psychology studies, I think, where there's some matter of interpretation where the person looking at the study says that people agree that this is kind of what we're manipulating in the study. So that depends on the study design, right? What we're measuring is just the black box overall output. We're measuring the overall utility. It's up to you to interpret what was the manipulation you made in that study and what does that mean. Is that answer your question?
I mean, that's in some sense tautologically true, but what are you doing to maximize the chances that I will interpret this the way you want me to interpret it as a reader of the paper?
In the specific game versus efficiency case, we're changing the incentive structure too. So in the efficiency case, you're paid per button click that you're getting done. In the game, you're going to get paid for minute playing the game. Okay, so it doesn't matter how many clicks you get done. That's just up to you. You're motivated to do whatever you want there.
All right. Yeah. Okay. That's what I sort of wanted to understand. So
Okay,
how you're going to tease apart these things because they are tightly intertwined. And
Yeah.
It will definitely depend on your study design. But that was the kind of answer I was.
But that's exactly one of the advantages of the method is you can tweak either a little bit, or you can tweak the whole thing in one go. And that's also why one of the things with the multi-step process, where the more complex tasks where you can split them up into the individual parts, and you can see what the results are there, and then you can combine all of them and do the studies for the combined version, and then that will teach you something about that will tell you something about how they match together. So that's one of the advantages. And the idea, or hopefully eventually what we get is sort of more of a, once people start doing this enough, well, essentially get a library of what works and what doesn't, and how much does it work. And that's sort of the idea. That's probably not our task, but other people can do that.
I'll ask another question. So you talked about these learning tasks and that people might choose between an interface where I suppose it's easy to use initially, or easy once you've learned it to use.
Yeah.
But I don't think people are particularly good at judging that based on whatever they will see before they have to make the commitment to do this. So clearly you can, at one level you can just study perceived ease of learning or something like that. But do you have any ideas of getting at some of the deeper issues? Could you really use this economic approach to get at actual ease of learning as opposed to what people think is going to be easy to learn?
One thing you do get here, which I didn't show here, is we're computing these survival curves. So we get to see over time how many times did a person do the task, or when did they drop out of the study. Okay? And that can show you that maybe they learned things initially and then there is a big problem when they got to this part of the interface or something like that.
And we could also, that's why that's one of the advantages of the auction method that we talked about, is that we will be able, if we can continue having people work on this interface, we will be able to observe their learning over time if we can get the same workers to come back and perform new tasks. So I agree that they probably up front won't be able to say, oh, I think this one is going to be easy to work on once I learned it. That requires actually sitting down and doing it. But if we can observe them repeatedly, then we can get an idea of how much effect does this ease of use have over time.
I'm not sure I understood. Are you going to have them rebid over time?
Yes.
Or, oh,
yes.
Okay.
Yes.
All right.
Exactly.
My
yes.
assumption was that they bid at the beginning and then they
No. They bid every single time. So and that's hopefully that will exactly get at what you were asking about.
So the point is that the amount you're paying people is still randomized. No, they're bidding. So the problem with this methodology, what I'm worrying about, is how do you ever test Emacs? Because
getting people, we have to pay them a lot to start using them.
for a week of my time to read the manual.
Yes.
At the end of a week, I want to commit to that for the rest of my life.
Yes.
Right?
Yes.
It far exceeds Notepad.
Yes.
But you can't tell that in the sort of the initial 10 minutes that you'd be considering your bid.
Well, we can run these studies long term too.
So that's a perfect example of something that would have to run over a long period of time, and we'd have to get people. So you run them once and say, well, you get Emacs on your screen. You have to do whatever it is, save a file, which is bad enough in Emacs, and then you can, and then we have people have to bid on that, and then you then go and actually have them do it. And then you do it again the day after. You do it again the day after. You go back to the same people and say, how much do we have to pay you to do it tomorrow? And you can observe over a week whether or not we have to pay them less and less.
So to compare Emacs with another editor, you'd have to start with two separate populations. One that you were saying, how much will we have to pay you to learn Emacs? And one you're saying, how much will we have to pay you to learn Notepad? And then later in the study, you have to merge the two populations and say, how much will we have to pay you to edit this document?
Well, if we're just interested, oh, sorry, yeah.
It's 11 o'clock.
Yes.
So if you'd like to continue, anybody wants to come and continue our conversation with these guys, great. If you want to stay through lunch.